When we execute a query against some database, we would get some data as a result, and such data is called dataset. If we want to combine several datasets, that is to combine several queries into one, we need to use set operators. I will now jump here to this web page to see some of those set operators. First, we have union all. So if this is one dataset, this is second dataset, union all will glue them together into one big dataset, which will have all of the rows from this purple and from this green dataset. But if we use union without all, in this case, we would get the same rows, but without duplicates. It is also possible to use intersect. Intersect means that we are looking for rows that exist in the first dataset and in the second dataset, and in this case, that is only the row numbered 2. And we also have except. Except is looking for the rows from the first dataset that do not exist in the second dataset, so we would only get row number 1. Now, in order to use these set operators, our datasets have to fulfill some conditions. First, they need to have the same number of columns. Second, order of those columns should be equal, that is, their sequence should be equal from left to right in the first dataset and in the second dataset. And we can only connect columns that have the same or similar data type. Now, let's see all of that in our examples. I will now jump here to Monet, and I will first create one sample table. And this table will be called above table. This table will be used for a query that will give us this purple dataset, that is the first dataset. And we will also fill this table with some data. And then I will create one more table. We need at least 2 tables. This table will be called below table. Now notice that this table also has 2 columns, and also they are of different data type. This is char and this is varchar. They are similar. They're all about text, so it is possible to connect these 2 columns. And it is the same with this second column. Here we have tiny integer and here we have small integer. So I will now run this, and I will fill this second table with some data. And then we will look inside of our tables. I will first use this to see our first table. So it has rows A1, A1, B2, B2. And we will also look at our second table. It is similar. It also has rows B2, B2, but it also has some different rows like C3 and C3. I will now clean my screen. Let's start first with union all operator. So I will now do union all between our 2 tables, and we would get this. So first 4 rows are from the above table, and bottom 4 rows are from the below table. And then, of course, we have all of the rows. We have all 8 rows. But if we use union without all, in that case, we won't have any duplicates, as we can see that here. So we would only have 3 distinct rows. We can also see how to use intersect. This is an example for intersect. We are looking for the row that exists in both of our tables, and the only row that exists in the both of our tables is B2. And we can see it here. And when we are using intersect without all, in that case, we will not have any duplicates. It is similar with except. Except will also give us result without duplicates. And this time we are looking for rows that exist in the first table, but not in the second. And that is the row A1, because it is from the first dataset, but it doesn't exist in the second dataset. Now, is it possible to use intersect and except with all? Yes, it is. It is possible. So I will now have an example for intersect, but I will also add this all specifier. In this case, we would have an intersect that is B2. Like before we have intersect, we had B2, but this time all of the duplicates will remain, so we will have 2 rows B2. And it is the same with except when it is combined with all. In this case, again, we would get, like previously, A1 row, but we would have duplicates in our final data set. I will now clean my screen. When we want to sort that big data set that we get as a result, where we should put our order by clause. Well, we cannot use it separately for each data set because we want to order the big data set as a unit. And for that, we actually are going to place order by in the second, that is in the last data set. So here is an example of that. So we have to use order by with below table because that is the second table in this statement. So when we run this, this will work. Now our number column is sorted in descending order. And one more thing, if we have two data sets, do they need to have the same names of a columns? Well, they do not need to have the same names. And in that case, what is important are the names in the first data set. For example, here in the first query, I use aliases L and N. So if I run this, the final data set will use those L and N as names for columns. But from this second data set, we will not use any names. So it can be anything here. Any names of columns will be acceptable in this second query, and this will still work. I will now clear my screen. It is possible to connect several data sets by using set operators. In that case, we would chain connect them by using several set operators. Now let's see an example. We will first do a union all between two tables, and then we would do except with below table. And this would be our result. In order to understand how this works, I will first divide this statement into two parts. I will first give you a result of these first three lines. So I will run this. So we start with this table, and we also start with our below table. And then we will notice that in these two tables we have duplicates, but we are not using except all, we are using just except. So the next thing that will happen is that all of the duplicates from these two tables will be removed. If we jump here to this web page, we can see our two tables, and the first thing that will happen is that all of the duplicates will be removed, as we can see here, and then except will work on these two tables. So the only row that exists in this first table and not in the second table is row A1. So this will be our result. And we already saw previously that that is really a result of this statement. I will now clean the screen. I will now show you the similar example, but this time we will use except all instead of except. So I will run a statement like this one. I will run it, and this time we would get 4 rows. Now, in order to explain you steps, how do we get this, I will jump here to this web page. And like previously, we have our two tables with 8 rows and with 4 rows. But this time, because we are using except all, no duplicates will be removed. And when we compare these two tables, we will see that we have 4 rows that belong to both of these tables, that is data sets. So we have these 4 rows that only exist to the first data set. So these rows will make our final result. We can see that result here. It is the same as here, only the order is different. Here we have A1, A1, B2, B2, and here we have B2, B2, A1, A1. I will now clean my screen. And for the last experiment, we will again run our statement, but this time we will also add this keyword distinct. We will use except all, but with distinct. And in this case, we would get the result with 6 rows. So how is this possible? Well, again, we will go here to this web page. Like previously, we have this table with 8 rows. But this second table will be transformed into a table with only 2 rows because we are going to apply a distinct on this smaller table. So we would get something like this. We would have only a table with 2 rows and table with 8 rows. And when we calculate except operator on them, we would get as a result these 6 rows as we saw here. I will now clean my screen. Here I will show you one example with intersect. So we will use statement like this one. It is the same as this previous example, just instead of except all, we will use intersect all. So I will run this, and this is our result. This result is result of these intermediate steps. First, we will do an union all between these two tables, and this is distinct below table, this small table data set here, and then we will calculate intersection between these two data sets, and this will be result. Now this is a little bit different than in some other databases where INTERSECT has top priority. For example, if we run this statement where we have used parentheses to enforce priority of INTERSECT, we would get different result. So this would happen if INTERSECT had a top priority, but this is behavior inside of MonetDB. I will now clean my screen. We are now ready to make two conclusions. First conclusion is that in MonetDB there is no priority between set operators. They are all on the equal level, and they will be executed from the top to the bottom. And the second conclusion is that when we are missing all specifier, then duplicates will be removed from the intermediate steps, not from the result. They will be removed from the intermediate steps, and then we would apply except, intersect, or union in the same way. So without all, duplicates are removed even before we try to use set operators. When we use set operators, we must carefully match our columns by their position. I will paste here one statement, and here the order of columns is not correct. Here is number column at position 1, and here is at position 2. So if I run this, I will get an error. And this is something that will happen often because it is really easy to mix order of columns, especially if we have a lot of columns. So it would be nice if we could match our columns not by their position, but by their names. And for that we can use keyword corresponding. So I will paste here one other statement, and I'm using keyword corresponding, and now columns will be matched by their names. So if I run this, I will get a correct result. And when we use only corresponding, we would get as a result all of the columns that are matched by their names. But we can limit a list of such columns, and for that we will use corresponding by. So we will say corresponding by, and then we will list columns that we want to be a part of the final result. So if I run this, I will only get column letter, but I can also add column number if I want to have both of the columns, so this would be the result. And this is how we can control order of columns in the final result. If we have some columns that are not matched, for example, here I will rename one of these two columns, so I will rename it as ZZ, so this column will not be matched. In that case, that unmatched column will not be part of the final result.